And then finally, I guess I'll just do this last question here. This one would be number 7 for today. And we'll save the rest of the problems for next time. But it's asking rank the given compounds based on their relative acidity. So let me go from, I guess I'll go from strongest to weakest, just like the solution did. So I have H3C, so H3CC. And then I have CH. I don't know if it's a formatting issue. We have CHHF. I don't know if this is one compound here. This is kind of confusing. I think it doesn't. So, oh, I have C triple bond H. That makes more sense here. I think they forgot the spaces. So this here is C, C here, H3C. So this is, so let me give me a second. This is H3C, CCH. So this is a methyl group, and this is my triple bond, and this here is the H. Let me just draw it out actually. So I have a triple bond. I have 3 carbons here. So this here and then this here would be H. Yes. So this here is H. Yeah, it's simply just this actually. Yeah. So that's gonna be. So that's the first one. This is just a formatting issue. That's screwing me up here. And then I have HF. And then NH3. And then H2C. So this is H2C double bond CH3 and then CH4, right? Okay. So let me draw this out here. So I have a double bond here, and then it's bonded to 1, 2, and then it's bonded to another, a methyl group here. So that's this guy here. I can erase this. And then I have these guys here. Okay, so I have basically these 5 compounds here. So 1, 2. So let me draw this in blue. So this is 1, 1, 2, 3, 4, and 5. It's asking us, okay, so it's asking us which is the strongest acid. So obviously strongest acid is HF, right? Ionic compound, hydrofluoric acid here, very, very strong acid here. So strongest, number 1 here is good. So I'm going to say that this here is my strongest acid. I'll put this as number 1. Next here is I'm looking at what is my next strongest acid. So I have an alkyne, and then an alkene, and then NH3, and then CH4. So if you look at our compounds here, if you look at it depends on the relative acidity, right? So again, NH3 here, it basically behaves as a weak base, right? We know ammonia the Kb of ammonia here is 1.8 times 10 to the negative 5, right? So again, it's a weak base. So it's actually not a very, very strong acid. So you can think of this as a weak base here. So again, this is my strongest acid. I know ammonia here is my weak base here, and I'm going to put the Kb value for you, just so you know. Kb here equals, and actually let me solve for the Ka for you. So Kb here, just give you some values, are 1.8 times 10 to the negative 5. So therefore my Ka of ammonia, I'm going to do 1.0 times 10 to the negative 14 divided by our Kb value here to get our Ka. Relatively, this here is 5.5 times 10 to the, sorry, give me a second. I think times 10 to the 18. To the 18. Oh wait, no, it's not. It's to the 8 here. Sorry. So give me a second. Negative 14 divided by, I think I input a positive 14 by accident. This is negative 5. Yeah, so it's 5.5 times 10 to the negative 5. Or times 10 to the negative 10 here. So as you can see, the Ka is pretty small. And then you have, again, Kas of our alkyne, and then our alkene, and then and then this here is our alkane or methane here, right? So you can probably figure out that methane here is our weakest acid. It's basically our number 5 here. And the reason why methane's our weakest acid is because it can't really, it's not going to accept more electrons here. Like if you look at the structure of methane, how is it going to accept more electrons? It's already saturated, right? So this here is definitely my weakest acid here. So this is not very good. So methane here is my weakest acid. Then it would probably, I would probably think that my alkene is going to be my next weakest acid. And the reason why I put my alkene next is if you think about the Ka value of basically an alkene, you can think of the acidity. It basically acts as a Lewis, a slightly Lewis acid here, and the reason why is that it can actually accept electrons, right? The alkenes here, the double bond here is electron rich, so it's going to basically I'm always going to be able to accept electrons here. So alkenes are pretty acidic. Alkenes are slightly acidic, but alkynes are even more acidic, right? They have 3 bonds here, right? So I'm gonna say that my alkyne here will be taking our number 2 spot because it can accept basically twice the amount of electrons than alkenes can here. So depending on that, and again, what you can do is you can actually look at there's a pKa chart here. Let me just bring that up for you here. And this here helps you with the relative alkene, the relative acidity or the pKa's of your organic compounds, right? And as you can see here, alkanes are all the way at the bottom here. Again, they're negative 50 here, right? Or sorry, not negative, but around 50 here, around 50. Right? Whereas hydrofluoric acid here is basically negative something. So again, very strong acid. Alkanes are going to be the weakest acid, and then it's going to be our alkenes, right? Alkenes are coming up next here. So alkenes here would be number 4, which makes ammonia number 5, right? Ammonia here, again, you can think of this as an amine, or you can think of this as, I can basically switch this value. I can switch this Ka value into a pKa value, right? I can take the negative log of this number here. And let me just show you the number here, what I'm going to get. I'm going to get here, a pKa here is about 9.226 here, right? So again, if you look at our chart here, 9.26 is about the protonated amines here. And this here is going to be pretty, it's going to be more acidic here. And alkynes are actually going to be even less acidic than that here. So I can think of this as, this here will not take our number 2 spot. So number 2 spot is going to go towards our ammonia, and then 3 will be alkyne, and then alkane, and then our methane, right? So again, if you look at this chart here, the most acidic here, obviously, is hydroiodic acid, hydrobromic acid, hydrochloric acid here. And as we go down the pKa, as we increase our pKa's, it's going to be least acidic, right? So as you can see, HF is obviously number 1. Number 2 would be ammonia, right? A 2 would be ammonia, which would be the protonated amines here. So NH3 here would be about would be our pKa's, and then let's see, and then so 9.26 here. 3 would be our alkyne, right? Alkynes exist kind of here at pKa 25, and then it'll be our alkene, and then our alkane here. So this is 1, 2, 3, 4, and 5. So they got it a bit mixed up here. They're missing NH3 should be number 2 here. So I'm going to say solution is incorrect. The correct order is strongest acid here would be HF, and then it'd be NH3, and then our alkyne, alkene, and then alkane here. So this solution here is incorrect. So again, thank you so much for watching the stream here. Again, my name is Joey. I stream basically from Monday to Friday. Monday, Wednesdays, and Fridays are my chemistry stream. Sorry, my math stream, my bad. And Tuesdays and Thursdays are my chemistry stream. So you can stay tuned for that. So again, thank you so much for tuning in. Again, stay healthy, stay safe, and have a great day. Take care.